Hello, my name is Joe Darcy. I'm an engineer in Oracle's Java Platform team, and I'll be speaking today about small language changes in JDK 9. First, however, we should mention that there was a very large language change made in JDK 9 as part of modularity, that is Project Jigsaw. There's a new kind of source file, a moduleinfo.java file that's used to declare dependencies between modules, as well as to declare what packages a module exports and other information like that. There's much more to be said about modules, and to learn more about modules, I recommend you listen to the Modules in JDK 9 talk by my colleague Alex Buckley. For the smaller language changes made in JDK 9, they come in two categories. One is a set of planned refinements for Project Lambda from JDK 8 and Project Coin from JDK 7. And the second set of changes involves making the deprecation facility more informative. Project Coin in JDK 7 was a collection of half a dozen small language changes, and we made further refinements to 3 of those in JDK 9, Diamond, Try with Resources, and vararg warnings. The small language changes included those updates to Coin, as well as 2 updates related to Project Lambda from JDK 8, and we'll speak through these in turn. First, safe varargs on private instance methods. You could write code like this for some time, even back in JDK 5 or 6, using the utility method arrays.asList in a platform to more easily create, in this case, a list of strings. However, when you compile this code, if you were diligent about your warning messages, you'd note a warning like this. Warning, unchecked generic array creation for varargs parameter. So what's going on here? This warning is actually mandated by the Java language specification because it's possible something bad could be happening. That something bad is called heap pollution, and it's discussed in detail in the specification. However, when you call the platform arrays.asList method, nothing bad actually happens in this case. The platform method is not misbehaving, so this error is uninformative, even though it's mandated by the platform. We didn't think that was a very good situation, so in Project Coin, we created a facility to get rid of these uninformative warning messages. And that facility was the safe varargs annotation. If a programmer applies the safe varargs annotation to a vararg method, it lets the compiler know that the programmer is asserting that the varargs method does not misbehave, that heap pollution does not occur. And because of that, the compiler is justified by the updated specification to not emit warning messages at the declaration site of the method, and more importantly, any of the call sites of the method. So now, as of JDK 7, you don't get warning messages calling arrays.asList. Because of the design of the annotation facility, annotations are only inherited on classes, not interfaces or methods. Therefore, the safe varargs annotation can only be used on methods that cannot be overridden. What are the kinds of methods that can't be overridden? We can't override final methods or static methods. Constructors also can't be overridden. From the VM point of view, constructors are just very special kinds of static methods. There's another category of methods that can't be overridden, and those are private methods. And we omitted those back in JDK 7, but now in JDK 9 we've gotten around to adding them. So we had a very small update to the Java language specification to now also allow safe varargs on private methods. Next, effectively final variables and try with resources. As a reminder, with the try with resources statement, you have a try block that manages your resource R in this case, and the compiler internally translates this into a class file roughly equivalent to this, where there's a finally block wrapping the try, and in the finally block, close gets called on the resource as long as it's not null. Now, it's actually a little more complicated than this to give better exception handling. So in terms of full disclosure, this is what the full desugaring looks like. We don't have to worry about this as programmers because the compiler takes care of this for us. So back in JDK 7, the requirement was the resource to be managed by the try with resources statement had to be a fresh variable declared as part of the statement. That wasn't the original proposal. Originally, you could use any expression that had the right type. If it was the autoclosable interface type that had the close methods, that was fine. However, we noticed there was a problem with that proposal. We see that here. Let's say you have your resource R initialized to a new resource. You manage the variable R with your try with resources statement, and within the block, you make it point to something else. Now, when you come to the end of the try with resources block, which object should have its close method call? Resource 1 or resource 2? We decided we didn't want to have to solve this problem, and the solution was to require a fresh final variable to be used with the try with resources statement. However, that was a little overly restrictive, because if the expression was already a final or effectively final variable, this problem wouldn't occur. So in JDK 9, we've relaxed the rules, so if you already have a final or effectively final resource, you don't have to declare a new variable for it. So instead of declaring the resource R2, in this case, you can just reuse your existing resource variable R. A little simplification that gets rid of some unnecessary boilerplate in the code. Next, we'll talk about Diamond with anonymous classes. Diamond uses type inference inside the compiler to allow programmers to avoid having to type explicit type parameters when calling constructors. So back before Diamond, if you wanted to do something like initialize your list of maps of strings to integers, you'd say call new array list, and you'd repeat those type arguments, map strings of integers. But you don't have to do that anymore. Now you can just say new array list less than greater than, and the compiler will infer the rest for you. Now this language feature is very effective at removing the need for explicit type arguments. However, there are some cases you can't use it. Because of a bad worst case interaction between Diamond and anonymous classes, you cannot use those with each other. The problem is there are cases where type inference can infer something called a non-denotable type. That non-denotable type is outside the type system we can use as programmers, and it cannot be represented in the class file that needs to be generated for the anonymous class. However, that's a worst case outcome. In many cases, a denotable type is inferred, and that could be represented in a class file. So we thought this restriction was a bit unfortunate, and we did note when we were finishing up Project Coin in JDK 7 that in the future we might relax this restriction and allow Diamond and anonymous classes to be used together as long as that worst case outcome didn't occur. And that is indeed what we've done now in JDK 9. We've loosened the restriction, and now you can use Diamond with anonymous classes in many cases. In JDK 7, we found that Diamond was very effective at eliminating explicit type arguments in over 90% of the constructor call sites. And with this new enhancement, we feel that allowing Diamond with anonymous classes will allow removal of a large fraction of the remaining 10%. We've had good experiences using this feature in the JDK codebase and eliminated hundreds of additional call sites. The next two small language changes are updates to the project Lambda features that were added in 8. First, underscore is no longer an identifier name. Starting in 8, the compiler issued warnings if you used underscore as an identifier, warning that it might not be allowed in future versions of the platform. And indeed, now in JDK 9, it is not allowed. And what was a warning message is now an error. So why are we doing this? We want to reclaim the underscore as syntactic real estate and repurpose it for more useful things. Those more useful things are described in JEP 302, Lambda leftovers, JEP being a JDK enhancement proposal. As part of Lambda in JDK 8, you could add methods to interfaces that had code. These are called default methods. So these methods are non-abstract, and thus they have a method body. At the VM level in JDK 8, interfaces could have private methods, and these were used to help implement the lambdas and so forth. However, at the source level, programmers could not declare private interface methods in JDK 8. And now we can in JDK 9. You can declare both private static methods as well as private instance methods. How would you use such a private method on an interface? You can use them as helper methods to implement the other public default methods. And we've found this feature to be very useful in writing the JDK. The next two small changes are both related to the deprecation facility. First, we'll talk about deprecation warnings and imports. One of the ways we've paid down the technical debt in the JDK is to reduce the number of warnings in our code base. We've actually cleared all categories of warnings in large fractions of the code, and that has included eliminating the deprecation warnings. Now, when do you get deprecation warnings? These are discussed in the Java language specification, and you get them when you use a deprecated type, method, constructor, and so forth. And there's three ways you can resolve those warnings. You can stop using the deprecated elements. That's preferred when you can do it, but you can't always do it. You can propagate the deprecated annotation to the use sites. Now that's worse than the disease because you're expanding rather than contracting the number of deprecated elements. And finally, you can use the suppress warnings annotation to let the compiler know that you don't want to get this warning message anymore. So let's say you have your client library and you're using a deprecated library, and you want to suppress the warnings from the annotations because you get the warning message here and you want to get rid of that. So you might think, all right at the top of the class, I'll suppress the deprecation warnings and I won't have to do anything else. However, when you compile this code, you find you still get the deprecation warning. So what's going on here? Well, if you look at the warning message in more detail, the warning isn't from the body of the code in the class, it's actually from the import statement instead, right at the top of the file. Now, this import is mandated by the Java language specification, and worse, you can't use the suppress warnings annotations on the import statement. It's not syntactically allowed. So this warning is pretty unhelpful. If all the other uses of the deprecated type can be suppressed, why can't you eliminate the warning from the import statement? That doesn't seem very helpful. And indeed, we changed this behavior in JDK 9 by not requiring a warning message in that location anymore. And because of this, it's now tractable to clear a large code base of deprecation warnings, and we have an existence proof of that from the JDK. Both the java.base module and java.desktop modules have been cleared of deprecation warnings. What does deprecation mean? It's a facility that's been in the platform for a long time, but there's been some uncertainty about the semantics of it. Is something deprecated because it's harmful, or is it deprecated because it's going away? And if it's deprecated because it's going away, why haven't more items been removed from the JDK over the years? We made some progress in removing deprecated items in JDK 9, but we also thought more information needed to be conveyed in the deprecation annotation to distinguish between these different cases. And we did that by adding a new method to the deprecation annotation, the full removal method that was either true or false. It defaults to false. However, if it's marked as true, that's an indication to you as a developer that you should migrate away from using that because it will be removed in some future release of the platform. The tooling around deprecation was upgraded to handle this. That both the language specification as well as Java-C and Java.doc all had updates to handle this. And there's a new static analysis tool in the JDK, JDepreScan, that analyzes class files and jar files for uses of APIs that are deprecated in the JDK to give you additional warning that your application might be using them, so you can take some action to stop using them. So, in conclusion, modularity is the large language change coming in JDK 9, but there are many other useful updates. We went through doing planned language improvements to the language changes previously made in JDK 7 and 8. These are very straightforward to use, and you can use them in your own code today. And to start using them in your new code, you can download a version of the JDK for your platform. If you're interested in getting involved in the development of OpenJDK, you can look at the mailing lists on the OpenJDK website, and you can also get updates on OpenJDK by following OpenJDK on Twitter. Thank you.